My name is Bruce Colburn, and none of you have probably ever seen me before in your lives, probably. I'm the discipline chair for the Ocean Naval Architecture program. And unfortunately, there's so few of us that we don't get to teach in term 1 and term 2, so that's why you've probably never seen me or anybody else in the group. Just as a matter of question, has anybody here made up their mind to go into Ocean and Naval Architecture, or are you all thinking about it?
Pretty much.
There's a few hands doing this. Okay, so everybody's kind of thinking about it, and you're wondering, what's it all about? Is that the case? All right. Well, I'm going to try and tell you, and part of the reason for showing this video was to give you some idea of the sort of thing that goes on, and that's probably the biggest thing going on in the world right now, so it's, you know, it's the nice one to point to. And that's an offshore structure which is much like the ones that are here, except somewhat bigger. Australians, everything is bigger. And so I'll just walk through this presentation, and then, if with any luck, actually there's so few of you, I can take you on a tour of the lab downstairs if anybody wants to go after. Another one of my colleagues is coming down, and in case there was a mob here, we thought we'd have 2, but you people are handleable by 1. So anyways, so just to give you some idea of what I'm going to try and talk about, I'm going to try and explain to you what offshore or ocean and naval architecture engineering is, because of course it's a bit unique, it's a bit unusual a course to take, and I'm going to obviously tell you a little bit about the program here, and usually people are interested in what the work term possibilities are, so we'll try and give you some idea of what's going on there. And then I'm going to show you some salary numbers and career prospects and that sort of thing. Most of it is from the US, because Canada doesn't publish very much stuff this way, but some of it is just interesting numbers. Don't put too much store in it, but you know, it gives you some idea what's going on. And then I'm going to make a little pitch for graduate degrees, and I know you might all say, oh my heavens, we're only started this degree now, never mind talking about graduate degrees, but sometimes it helps to think a little bit before you move along too far. And then I'm going to give you some free advice, and you all know what free advice is worth, so but based on my own experiences, and in fact, most of you wouldn't know this, but I actually was in your same situation only about 35 years ago, and in this same building. So I've come through more or less almost everything that you're going to go through, including schooling, maybe graduate degrees, and various working experiences. So I can give out, at this stage of my life, I can give out advice. And then if there's any questions after, you can ask them, and if people want to stay and we go down and just take a look around the labs and talk about the things that are sort of relevant to this program, we can do that after too. Okay, so what is Ocean and Naval Architectural Engineering? Well, it used to be known as Naval Architecture, and when I first started here, it was known as Shipbuilding Engineering. Things are broadening out a little bit, but basically there's 4 kind of things lumped in under that. And the most common one now is, or the more generic term is ocean engineering. But really that is when we talk about equipment, not ships, not platforms. But when we talk about equipment like oceanographic equipment, ROVs, things like that, that's kind of the field of ocean engineering. Same sorts of things apply. Naval architecture is kind of the traditional business, and that's any vessel that moves. So in other words, it could be ship, it could be submarine. As long as it moves from place to place, that's a naval architecture problem. Offshore engineering is kind of a subset that's really aimed at the oil industry. So in other words, that would be platforms to produce oil usually, or to explore for oil. And then the final thing is marine engineering. And that is essentially worrying about the machinery that goes in all of those things. So that's a kind of a broader category. In the good old days, there was naval architecture and marine engineering. And then in latter years, ocean engineering and offshore engineering sort of crept into it. And so that's just to give you sort of the flavor. People use all these terms kind of interchangeably, and just to give you some idea of what we're talking about. Sometimes even we don't know what we're talking about when we talk about these things. Just to give you some trivia, just to give you some idea that ocean, because we're always trying to justify ourselves when we're in the ocean business, 71% of the earth is covered by water, seawater. So that's, that's quite a bit. People are only sitting on about 30% of the earth. That's the land part. Canada has the longest coastline. Canada borders on 3 oceans, and if you count the Great Lakes as a kind of a little inland ocean, Canada has the longest coastline of any country in the world. A lot of it is in the Arctic, and that means a lot of it is frozen. And so we spend time worried about that. The vast majority of the world's trade moves by ship. Into Newfoundland, almost everything moves by ship. Almost everything that comes in here of any appreciable size comes in on a boat. And so for us, it's an issue. Right now, the largest container ship in the world can fit, in one voyage, 18,000 containers. And apparently you can put 1,000 flat screen TVs in every container, so that's 18 million flat screen TVs can be carried from one place to another at the same time. So that's a lot. There are about 100,000 ships, give or take, in the world, and when we say ship, we mean anything bigger than 100 tons. So fishing boats and pleasure craft don't count. And about 30% of the world's oil is produced offshore. So the upshot of this is there's a fair amount of activity in the world going on in the ocean. And in fact, there are relatively few engineers in the world who deal with it. And in Canada, we are it. The other point I wanted to make about offshore engineering and naval architecture is that really it's an interdisciplinary field. You cannot, because people have to go out on these platforms and have to go out on ships, and they have to be able to live, and they have to be able to go to work, and you have to keep them alive. So there has to be machinery, there has to be all kinds of things. Essentially, it's not a kind of a one discipline thing. What you study in this field is essentially the loads that the water and the behavior of the craft or the platforms of things as it relates to the fluid. But there's all kinds of other stuff that has to go on as well. So in other words, if we take offshore engineering and we throw in civil engineering, essentially those are the 2 groups that have to work on offshore platforms. Because usually for an offshore platform there's a foundation, and usually there's a lot of concrete. So it becomes a kind of a mixed civil engineering, ocean engineering problem. Same thing for subsea systems. Mechanical engineers spend a lot of time working on subsea things in concert with ocean engineers. And you can see the other ones, and getting down to sort of naval architecture, even computer engineering. Of course, that's sort of into everything these days. But for us, it turns into sort of marine simulation. And a lot of training is now moving over to simulation. So essentially, people who are going to go to sea, people who are going to execute, like that little video we showed at the beginning there where they move around big pieces of structure, a lot of that stuff gets done on simulators before it gets done in real life. And so the upshot is, even if you go into some other field, or this field, you can't end up working on the same sorts of things. And it's frequently, doesn't always entirely matter how you started out. What matters is where you sort of end up. Okay, to brag a little bit about our own program, because I'm supposed to do that. This is the only undergraduate engineering degree that you can get in naval architecture or ocean engineering in Canada. So this is the only place you can come and do this sort of degree and get an engineering degree. In the United States, there's probably, I think maybe 4 or 5 schools now which offer this as an undergraduate program. And in Europe, there's probably 15 or so. So in Canada, it's the only thing on the go. And we are the only one that I know of anywhere with a required co-op program. So you will come out of this program, well, it doesn't matter what discipline you go into, you'll come out of this program with co-op experience. This is the only place you can get co-op experience and the ocean and naval architecture thing. And generally, we have good standing. This program has been here for, it's not the youngest program, Process is the youngest program, but we are the 2nd youngest program. And it goes back to my time, which is 30 years or so. So that's enough time to establish a pretty decent track record. And over the years, people have sort of done reviews on these things. The most oldest one goes back to 1996, and that compared us to all the schools in the United States. And we sort of came out better than most. The most recent, I don't know how many are familiar with engineering accreditation in Canada, but in order to become a professional engineer, you have to go to an accredited school, or at least it's easier if you go to an accredited school. and accreditation is doled out by the Engineers Canada. And in our case, on the most recent round, we were accredited for 6 years, and that's the longest time you can be. So in other words, they have to come and see you at a minimum every 6 years. If they're worried about you, they come earlier. But if they're not worried at all, they say 6 years is fine. And I can quote from personal experience that people in Houston say, we love MUN graduates. They actually said love, but I didn't want to go too far with this, so they just like MUN graduates. And so in terms of the sort of the co-op experience and things that people are getting, and again, really this applies to all of the disciplines, because it's not just the Ocean and Naval Architecture students that are working in the offshore industry, and it's not just the Ocean and Naval Architecture students that are getting work terms in the US. So you're, almost without regard to which one you choose, they will still like you. But we have more than our fair share. Okay? So, if you do elect to go into naval architecture and ocean engineering, you might ask, well, what are we going to learn? What's different about this? Why isn't this sort of just mechanical engineering? And essentially, most of what you learn has to do with how the water and the system, or the boat, or the platform, or whatever it is, interact with each other. So essentially, the first thing, of course, every boat, every platform has to do is stay on top of the water, for the most part, except submarines. So most ships, first requirement is must float. Second requirement is must stay upright. So that's the first thing you learn, usually, how to make sure that happens. Second thing is usually how to make it go. So assuming that you're standing there, things are upright, you're floating, the next thing is where do you want to go? So that's usually for ships. We offer a sort of specialized stream of structural courses, because usually when you talk about ships, the structural demands are a little bit different. So in other words, when you talk about a building, there are loads on the building, but the building is not moving. So the building is not trying to go somewhere at the same time that it's being loaded up by weights and people. So in our case, you have to both deal with the sort of the static loads of the structure, and you have to deal with the fact that it's moving around and the waves are tossing it around and all those other things. So the requirements are a little different. And we touch a little bit on offshore engineering, and usually that means a fixed platform. So it can be a floating platform, or it can be a fixed thing that's got a foundation. And so either way, in this case, you're not trying to make it move anymore. Now you're trying to make it stay still. So you're trying to say, what are we going to do to withstand all these wave loads and things to keep the structure in place? We have courses in submersibles, not full-blown military-type submarines, but usually now little underwater robots that go off and do their own little thing. So again, controlling a vessel that's underwater, that's not afloat all of a sudden, is an issue. And finally, by the time you get there, there will be courses in marine engineering. And that is really the machinery that goes into all these things. And I'm sure you've already had one course in sort of design. There will be a series of courses in design, which essentially you take all of those individual things that you've learned and try and make it all work together in a system that people can work on and live in and survive on. So that's what design is all about, the integration of all those things. Okay? So that's it in a nutshell. If you already know all that now, you can go. You're done. But most people don't. Okay, right now there are seven faculty members in the group, and that's why we don't get seen in term 1 or engineering 1. And there's the names there, and essentially what people are specialized in. I'm at the bottom of the list because, well, not for any reason. I'm just at the bottom of the list. We have people who are specialized in structures, safety, some in simulation, 2 people in hydrodynamics. A lot of people have some expertise in ice, and ice is, and effects of ice on offshore structures and on ships, icebreakers and things like that, is in a way sort of a specialty of this university. And if we go downstairs after, we'll show you some things that are going on in ice research. Some people get mixed up in these things as part of work terms. Some people become graduate students. Some people even get to do little undergraduate projects. And frequently, as a kind of a design exercise, people take on icebreakers or platforms for use in ice. So it's a bit of a thing it's the thing in Canada, obviously. It's minus whatever it is outside now. So ice is an issue. So the other thing that's going on is, as you may or may not be aware, the faculty as a whole is expanding. And right now we take 30 students out of your class. Out of term 2, we can afford to take 30. We are planning over the next couple of years to go up to 50. And part of that will be more faculty, more courses, and probably separate streams in naval architecture and ocean engineering. So there's kind of a general plan to expand this program and all the other programs. But in our case, it will probably mean that we can take an extra 10 or 20 students out of engineering 1. So hopefully 3 more soon. Okay, most people are a little bit interested in co-op placements, and in this thing, because we're the only school in Canada, and there is activity certainly on the West Coast. Also, in a strange way, there's lots of activity in Ottawa, because that's where a lot of the government's money gets spent, and so there's a lot of going-ons about ships in Ottawa. Essentially, work-term opportunities for people who go into ocean naval architecture are both national. There's a fair amount of activity here, obviously, with the offshore, but there's probably more opportunities nationally and internationally because the field is smaller. So essentially, we end up placing students almost everywhere in the world. It's a little bit harder to go international, and frequently people do that on their own initiative. That requires a bit of planning. So if you're interested in international opportunities, if you're interested in going to Europe, particularly Europe, you need to think about it a semester ahead of time at least, because frequently you have to get visas and things like that. So that sort of thing takes a little more effort on your part. If you just sort of go into the normal co-op competition, it's not so easy, but a lot of people arrange their own things in Europe, and a lot of the professors have contacts, and a lot of the senior students also have contacts. Going into the US, not so bad, because the free trade agreement covers you people as well. And going into the rest of Canada, obviously, is fairly easy, and getting a job in Newfoundland, particularly now, is generally not too difficult. There's a lot of offshore activity, and there's a fair amount of research activity as well. So generally, things at this stage are usually pretty good. The semester we're looking at now, there was a bit of a dip actually in the number of jobs. But generally, the placements are, and I think even this semester it was higher than 90%. So, there's plenty of opportunity, and the fact that it's relatively small group here and a relatively focused market everywhere usually means you're in pretty good shape. So there's just some examples there of the companies and the sorts of jobs that go on. And that picture is a bunch of students who are on a work-term placement and are being used as guinea pigs in a lifeboat. So that's sometimes fun. Anyways, in terms of sort of career choices, I don't know how many of I suppose you all do think a little bit about careers, but frequently what happens to you while you're in school and what happens to you while you're on work terms makes a difference as to what you choose for careers. People frequently change their minds as they go along, and that's a nice opportunity to discover what you like or don't like. So essentially, it runs the sort of the gamut. If you think of education as the sort of the starting point of the process, there are careers in education. You can end up as a professor. You're all thinking, oh my goodness, this. I see anybody laughing at that. That's probably a good sign.
That was me.
What's that?
That was me laughing.
Oh yeah, okay. The professor is laughing, but he didn't start out as one. Anyways, there's a fair amount of activity, certainly in the local scene, in research and testing. There are companies set up to do this. There's a big federal facility next door. There's a fair amount of activity in this university. There's Seacorps next door. So there's all these. There's an unusual concentration of research activities here, and in essence, that was for the most part my career, which is actually a pretty good gig. The other thing that you will see increases in are regulation and inspection. The marine business is particularly, it's a hazardous business. The bottom line is, it's probably the second most hazardous thing after going into space. Obviously, you have to be very careful about the environment. People who are working offshore, anybody who saw the video, even in the shipyards, you saw the amount of safety equipment that the fellows who are actually doing the inspection are wearing. all of these requirements are getting more and more stringent as they go along, and that means that job opportunities in those sorts of things are growing bigger and bigger. And so there's lots of inspection, some of it associated with the governments. The marine business is peculiar in that it has, well, they're not really companies, they're actually non-profit agencies. If anybody's ever heard of Lloyd's Register, or the American Bureau of Shipping, or Norske Veritas, these are all agencies that are not really companies, but they're set up to do marine inspection and things like that. Almost all of them take students. So and all of them offer career opportunities. There's people here now who work for those. The next, in my mind, the most interesting thing in a lot of this case is design. And Canada now, even in this country, there's lots of design activity going on in the world. Canada has been a bit slack in that department over the last couple of years, but they have certainly the government has recently said we are going to get back into producing government ships. So that includes for the Navy, and that includes for the Coast Guard, science, all of those things. And they have committed somewhere upwards of $40 billion over the next 10 years to do all of that. So clearly for people like you, $40 billion spent over 30 years or so, by the time that program starts and ends, that would be a career. So it's there. And obviously, following out of that, there's going to be a certain amount of ship construction. And, you know, in addition to that, there's things like Bull Arm. I don't know if anybody's ever been out to Bull Arm. Well, that's a construction site, essentially, with a dry dock. So it's for some part of its life, it's a marine structure. And then there's the whole business of ship operations and maintenance. And that in itself, as I said earlier, there's 100,000 ships in the world. Everything that comes into Newfoundland comes in on a boat. So all of it has to be maintained and operated, and all of those things people who've come through these sorts of degree programs can be involved in. So there's lots of career choices, and I think, in fact, the opportunity is kind of expanding. Okay, and here comes this is my few little tidbits of information from the United States, actually. Essentially, the U.S. Bureau of Labor Statistics makes predictions about what's going to happen in the world. Some of them are pretty simple, but basically they're saying that the opportunities for shipbuilding and naval architecture are going to grow at about 10% over the next 8 years, I think. Yeah, no, 10 years. And that's sort of in keeping with average. In Canada, that's likely to be a little bit bigger because of these enormous expenditures that the government is going to put in. So essentially, lots of opportunity on the North American continent. I like this one. This is actually from the Civil Engineering Association of the United States, and you'll notice that ocean engineers make the most money. I thought I'd pick that out. That may not be true in Canada, but it's certainly true in the United States, at least amongst this group, and it's significantly more money than everybody else. And these are the average salaries for, everybody said $170,000. I could live on that. That's what you're all thinking, isn't it?
Just
Yeah, it'd be okay. Better than student wages, eh? Anyways, that's the median salary for ocean engineers in the United States right now, apparently.
When you become a professional engineer.
What's that?
Not when you're in training, when you become a
No.
professional.
You have to work for a while, but it's something to shoot for. And poor old coastal engineers are way down there. The rest of them are sort of irrelevant to us, actually, but coastal engineers are close relatives. And so for some reason, they're almost half. But I thought I'd put that in there just because it was too good to pass up. Okay, I'm going to make some predictions now, and then later on I'm going to give you some advice which is going to tell you not to pay too much attention to people who make predictions. That comes in the next slide. In terms of the way things are going to unfold, it is likely there will be continuing offshore oil development off the east coast of Canada. That's pretty likely. Another thing that I think is going to be an area where people could get interested in is going to be wind farms, offshore wind farms in Northern Europe. These are my economic predictions for the future. The Naval and Coast Guard fleet replacement in Canada, these are all things that might draw you into careers. The Naval and Coast Guard fleet replacement in Canada is almost a given, as long as the government doesn't run out of money, which is not showing any signs of yet. There will, in all likelihood, be increasing activities in the Canadian Arctic, which means, and the Russian Arctic and the American Arctic. So it's all the same, Arctic. And the Americans are predicting that the shipping trade will go up, so it's likely that you'll see a kind of a steady but not spectacular increase in worldwide shipping. And as I said earlier, this whole business of marine safety and inspection. So in my mind, these are kind of the growth areas. And that's the picture is of an enthusiastic graduate student sitting on a. Has anybody seen the movie Dr. Strangelove? You know when he rides the bomb into the. Anyways, this is somebody mimicking this thing. If you're familiar with this like movie trivia or anything, so we do have a sense of humor in this group, or we try to, anyways. Okay, I was going to make a little pitch now for graduate degrees. I'm sure most of you are not thinking too hard about graduate degrees at this point. You're saying like, Lord, I'm hardly through this one. I'm not even started yet. But if you are interested in doing graduate work, it does give you a chance. It gives you a chance to be a poor student for an extra couple of years, and but it does pay in the end. And you'll notice right down the bottom. I'm big on salaries these days. In very fine print down the bottom there. It says that basically, if you have a PhD, you're likely to earn about 35% more than someone with a bachelor's degree. So it's not an entirely self-sacrificing thing. And that's even for people in industry. And in fact, that's probably becoming more prominent. You don't have to just become a professor if you get a PhD. And some people just stop at master's students. But we're trying to encourage people to think about it, because there is a lot of activity around here. There is a bit of a benefit to going into a degree, never mind the fact that you get to think about things for a long time on your own, but there is a kind of a financial return as well. And again, these are American numbers, but there's no reason why these numbers would be any different than in Canada. So think about it, and there's a flock. I don't think that's entirely a flock of graduate students there, but some of them became graduate students. How's about that? And so it is a chance to sort of, upgrade your qualification a little bit. And I know it's mighty tempting these days to just go take a job, especially after I dangled that $169,000, wasn't it? That was probably a bad strategy. Anyways, think about it. And if you are going to think about it, you need to start, like you're coming out of term 2 now, so you're going into term 3, term 4 comes pretty quick. Round about term 5 is a good time to start thinking about it, because you sort of need to start figuring out what you're going to do. And by the time you get to term 7, they have a thing here called a fast track option, which means if you've got all your work terms done, you can take your last work term, start on a master's, and then it saves you time. So in other words, you can get out faster. And so people who are lean in that way a little bit, or sort of saying, no, I'm so fed up with school. Term 7 is the time to sort of make up your mind. But in order to do that, you need to start thinking about it a semester or 2 earlier. So I just throw that out there now so that you've heard it. And maybe sometime a few semesters later you'll say, remember that guy? Anyways, food for thought. Okay, I'm going to give career advice now, one of which is don't listen to predictions, which I just made earlier. When you're picking something, pick something that appeals to you. People frequently tend to say, I should pick the job that's got the best career or the biggest salary or anything else like that. And all of these industries go up and down. So sometimes, one form of engineering is good, sometimes not so good. If you pick something that appeals to you and you're good at it and you're enthusiastic about it, you will always get a job. People will always say, they're the good ones. So pick something that you like. Don't worry too much about, a long time ago, does anybody remember what happened? No, maybe people are too young. The year 2000, remember everyone thought all the computers in the world were going to collapse? Yes.
Y2K.
Everybody was told to go into computer science. The year after that, and lots of people did, they said there's going to be enormous demand to fix all those poor, wounded computers. And in 2001, they all worked the same. And everybody said, well, we don't need those people anymore. And so don't pay too much attention to these sort of trendy things. Make up your own mind, figure out what you like. And as I said, if you're happy in your work, you'll always be good at it, and people will always say, there's a good person. And that's more reliable than economic trends, which will always go up and down. So that's piece of advice number 1. Piece of advice number 2 is don't pay any attention to the predictions. Actually, I guess that was 1 and 2 at the same time, really, wasn't it? The third one is there will always be some setbacks in life. I speak from experience. And don't sweat it. Sometimes it happens at university, sometimes it happens in careers. Sometimes it's a chance to do something else. Sometimes it's a chance to say, I need to work harder at whatever it is I'm doing. So, like I say, these things will always happen. Don't let them knock you down. and you'll be fine. So that's my three pieces of advice, which hopefully will help you. I've seen, as you all said, you were in the throes of decision here. This should well, if you pay any attention to it. Maybe I should have said don't listen to advice either. Maybe that's the other thing. Anyways, if anybody has any questions, now is a real good time to ask them. If anybody is afraid to ask questions in large public forums, you can send me an email after, and I will answer your question.
Is the oil and gas option still offered?
No, there's. I don't think there's any oil and gas options for your class now. So it's been canned for everything, hasn't it? Yeah. There are still, I mean, you can still do electives that are aimed at offshore operations and things like that in any of the disciplines. But as a kind of a formal option, it's not there anymore. There are still oil and gas courses, so people have to pick their own. And one of the things we are trying to do is we're trying to get into the later terms more elective choice. So in other words, there'll be less required courses in the end and more elective choices, so you can sort of plan your own program to some degree.
I'm interested in doing a master's in Arctic engineering, and I don't know if I should do civil or naval because the civil people told me to do civil. So I don't know what to do now.
To tell you the truth, I won't say it totally doesn't matter, but it kind of depends on which side of the thing you want to be on. The civil side of the Arctic engineering deals with shore-based infrastructure, things that are stuck to the ground, even offshore platforms that have got foundations. So to some degree that's that, and generally things that are made out of concrete. And the Ocean Naval Architecture side of things tends to look more at, the ship side of things. Ships, steel structures, things that float. So it's, if it's the Arctic you're interested in, I would say it doesn't matter too much. Pick the one that pick the one that sort of appeals to you.
I was wondering if you could talk about the focus stream of it. Is that still?
Funny you should mention that. By the time you people get there, the focus stream will probably be history.
Okay.
I don't know if that's
good
good
for you.
Okay.
What's that?
And that's good for them.
Dan particularly hates the focus stream. It has been, some people have used it the way it was intended, I guess, and some people have just sort of said, tell me what the minimum is I have to do. And I guess we've come to the conclusion that there are probably better things you could be doing. There are some technical things that were sort of left out for that and made electives and things. So we're in the throes now of sort of pushing that aside and replacing it with, it'll probably be replaced with 2 required courses and 2 elective courses. So that's the way that's going. It makes life simpler.
Another thing I'm interested in, do you have any graduates who got work with ROVs or AUVs?
Yes.
Yeah?
Actually, when we go downstairs, I'll show. There's a lab, a submersible lab here, where they've got AUVs, which are essentially programmable.
They're awesome.
You send them off and hope they come back. Sometimes they don't. And they also have some ROVs in that lab, so those would be tethered devices. So yes, there's there's specific courses certainly around the submersible control.
I'm enrolled in Math 2000 right now. Like, is that a benefit in any way? Like, they still take my math, will I have to repeat it?
Well, it gets you, no, you don't have to repeat it. No, as soon as you got the credit, that's okay.
So if I were to take like ODE or vector math or anything, that would still count?
That would still count, yeah. So you don't have to do those courses in order. So you can do them if a lot of people come in with them already done. The real reason we did that was because there's just not enough of us to teach all the courses. That's the practical answer. So, but it does make it a little convenient for people who are coming in with the credits already.